Thank you very much. Hello, everyone. It's great that the number of participants has not been changed significantly from the morning with this extensive schedule. I would like to thank you for keeping attending this nice meeting. And also, I would like to thank 6GSS. It's around 7 months or 8 months that I have joined this program. I learned a lot about this interdisciplinary atmosphere of this program. And I want to share my research direction that I decided to take during this months and apply also for some funding. I will be talking about sustainability-driven interactions of 6G and energy systems. This is actually key takeaway from the previous lectures, that we know that the commercial launch of 6G communications and the United Nations Sustainable Development Goals are both targeted for 2030. And in Europe, we have 2 programs called European Green Deal for the green transition and Digital Decade Policy 2030 for the digital transition. And this twin of transition, green and digitals, are both targeted for sustainable futures. For the digitalization of energy system, it has been stated there that around 584 billion of euro is required to be invested in the electricity grid between 2020 and 2030, and the significant part of this investment will be in digitalization of energy systems. And having a closer look at the energy transition at EU, we have this 4D approach: decarbonization, decentralization, digitalization, and democratizations. In decarbonization, know that it deals with using renewable energy and install solar PV panels on roof of all commercial and public building by 2027 and all new residential building by 2029, that target reducing green gas emission by 55% and reaching a share of 45% of renewables in 2030. And in decentralization, we are facing this trend, moving from the kind of centralized energy system to a more distributed systems of energy assets. And the main question in decentralization is that how can potential decentralized energy and efficiency opportunity be developed? And digitalization as a key enabler of decentralization and decarbonization, thanks to the smart technology that are being developed in AI, in connectivity, in data analysis, and in hardware as well. And the main question in digitalization is which digital solutions more facilitate these twin transitions, and in the democratizations deal with the empowering individuals to control their energy consumption and at the same time participate in energy market by producing energy by using, for example, solar panels that they install on their roof. And in this 4D approach, digitalization can be regarded as a main enabler of the other D approach. And the rest of my presentation will be most on this digitalization part and the role of mobile communication system that can play in digitalization of energy systems. Before that, it's good to have a look at the evolution of mobile communications from 1G to current 5G and in the futures 6G. A variety of technology advancement has been done in mobile communications from 1G to current 5G, and every 10 years we have faced new cellular generations. However, for the business and new value market, every 20 years we have some kind of new disruptive business. For example, during 1G and 2G, the most services that was offered were voice and text, and during 3G and 4G, the data in addition to the voice service were offered to the users, and it enables new disruptive business models on these data services that many over-the-top applications that usually we are using in our everyday life, they are enabled by this high data rate and ubiquitous connectivity that provided by 3G and 4G. And in 5G, from the beginning of the 5G, it was targeted that in addition to the voice and data as a traditional services, the objects, process, events are more connected to each other by using VR, AR, wearable devices, and Internet of Everythings, even a space tourism that we hear in the news, and tactile internet, holographic, AI, digital twin, metaverse. And these are the key enabling technologies that want to connect more objects than before. And from the 5G, from the beginning of 5G, 5G Advanced, and also for the future 6G, it is aimed to offer services specifically for some verticals. And that's why in the future we have more vertical specific services rather than the general services offered by 4G and previous generations. When we say that vertical specific services, we mean that each verticals, each industry have their own characteristic, their own requirements in terms of connectivity, computations, and 6G is supposed to provide these requirements for it and provide some vertical specific services, including health, energy, industry, and transportations. And for sure, this is not just a matter of technologies, and both technology, regulatory, and business should be hand in hand and support this vision to reach some vertical specific services that help digitalization of many verticals, including energy systems. Talking about the role of mobile communication system in many verticals, including energy systems, we should pay attention to the double-edged effect of ICT in general and mobile communication system in particular. In the one hand, mobile communication systems, when it expanded, it results in more carbon emission footprint. That is stated 1.4% of global carbon emissions comes from the ICT in general, and 4 or 5% of total energy consumptions come from the ICT. And from these figures, we can say that ICT is still a part of the problem, and we should also think about the energy efficiency and some energy efficient and sustainable design of 6G itself. And at the same time, the other edge is that ICT in general and mobile communication system enables sustainability in other verticals and help digitalization of other verticals, which result in avoided emission. And this avoided emission enabled by mobile communication technology through increasing connectivity, informed decision-making, and impacting behavior change. For example, in smart working, it has been reported that the ICT in general resulted in 39% avoided emissions. And in other verticals, we also expected such an improvement in avoided emissions. This double-edged effect should be taken into consideration when we are dealing with the digitalization of verticals by using services offered by 5G Advanced and 6G. According to this double-edged effect, my research directions go to two approaches. One approach is deal with the first problem, mobile communication, as a part of problem that needs some energy self-sustainability in the mobile communication systems, and coming up with some improving energy efficiency in designing 6G service from the bottom layer to the up layers of communication, and also increase use of renewables in the ICT sector and in mobile communications industry, in the device level, as well as in equipment used in radio access network and in the core networks. This is the first research direction that mostly match with my previous work. And the other directions that during this 6G ESS I started to think more about that, it's about enablement sustainability, which deal with the second role of mobile communications in sustainability that helps other verticals to avoid emissions. And regarding these research directions, coming up with some specific vertical slicing or specific vertical services that can be offered to the verticals depending on the requirements that that vertical needs. And also digital twin as a mega trend that in the future there were many digital twins for the physical systems of many verticals. For the rest of this presentation, I will focus more on the digital twin and going to some not very technical details, general information about this, that when we want to have 6G services for the verticals, the 6G trends that supporting verticals can namely decentralized intelligence, edge computing, digital twin, and also joint communication, control, and computations. In joint communication, control, and computation, in one services, we deal with the connectivity requirement and also at the same time taking into account the control loop requirements that usually run in every verticals, for example, in energy systems, dealing with some stability, resilience of energy systems, and at the same time providing computations and taking into account, for example, the delay that some algorithm to the end-to-end connectivity and end-to-end communications. From this perspective, maybe 5G Advanced and 6G is different from the past generations that mostly the expert from telecommunication industry was active in standardizations because they were supposed to provide general services for many verticals. But in 5G Advanced, in 6G, it is expected that experts from the verticals also participate in the discussion because they are part of the game and they should mention their requirements in terms of connectivities, computation requirements, and other requirements that we, for example, I as a researcher in wireless communication may be not aware of that, and I should get the requirement from that verticals. One of challenge is the lack of common language, view, and consensus between these experts from different perspectives. And sometimes it's good to look at the general architectures, and this will help to have some kind of common language, at least from the telecommunication perspectives. Starting from the bottom layer physical entity, that is the vertical specific physical systems. Their actuators, sensors are located there. And then, for example, sensor produce informations, and this information comes via communication networks. That may be some vertical specific slicing that provide the connectivity requirements for this physical system. And then depending on the use cases and depending on the analysis that we need, maybe it analyzed in the fog and edge computing, in the facilities near to the users to avoid much delay and to avoid long delay, because some critical use cases are happening, for example, in the energy system for the protection or for the situational awareness. This data should not be went through the cloud. And sometimes data also need to be stored in the data management platform in the cloud networks, and then that platform provide data for the upper layer via API, for example, and come up with some vertical specific application and services that run on top of the data available in the data management platform and using big data and machine learning analysis there. And these all layers are impacted and are, let's say, formed by the business and use cases and regulatory logics that mandate some specific requirements in different layers. In these different layers, that is some kind of end-to-end architectures, each layer has its own challenge, But the layer that are mostly impacted by the vertical is the bottom layer and the upper layers, because the verticals are more involved. For example, in the physical systems, the sensors and actuators needed for energy system completely different from the sensor and actuators needed for example, healthcare verticals. And also at the service layer and at the business and regulatory logics, they are different from a vertical to another verticals. And that's why those layers are more impacted by the vertical. It doesn't mean that the other layers are not impacted, but these layers are mostly impacted layers in terms of that the vertical should determine the requirement there. And among this layer, for example, let's look at the data platform management. The way in which data is stored and processed in coming years will change dramatically, because, for example, looking at the current trend that a small number of big technology firms, they hold and they have access to a large number of data. For example, Google, Microsoft, they have, or the social media provider platform, they have access to a large part of the world's data. And this could reduce some incentive for new data-driven business. But future trend is that large part of the data of future will come from the industrial IoT applications within private 5G or local 6G, or some new business models take place in the 5G and 6G, and this may change the game rules. And for example, for the edge computing, current trend is that 80% of the data processing and analysis are currently done in the cloud in a centralized manner, and 20% in the edge computing. And the future trend is that this proportion are likely to be inverted, that 80% of data are processed in the edge computing, and maybe in the locally accessed edge computing, locally accessed by the owner of, for example, a factory, owner of an industry. And then this also will change the ground, and maybe we can say that the winner of today will not necessarily be the winner of tomorrow. And these are happening in this end-to-end architecture. And in data space and edge computing, the more challenge, actually, it was the subject of my question to previous speaker about the intra-sector and inter-sector data sharing. Because, for example, today, ChatGPT came into existence because we had good, high-quality data available. But in the future, for the IoT application and for digitalization of the verticals, including energy system, healthcare, the access to the data and availability of high-quality data is very important, and we are now at the earliest stage of providing such a data, because before that we need some kind of IoT application that provides such a data that enable machine learning expert to work on this data and to provide some new data-driven and innovative services. Now, there are some current regulation and directive and action plan in Europe, and this is General Data Protection Regulations, also Open Data Directive, that is for the openness of data. For sure, we need some non-personal data, and some kind of data needs to be shared for democratization and also for letting the business and the other firms to come up with some innovative data-driven services. And in digitalization of the energy system, for example, in the EU action plan that was published around 4 months ago at the end of 2022, and it has been mentioned that investing in the following technologies, a smart IoT device and meter, 5G and 6G connectivity. And the third one I want to emphasize, a pan-European energy data space powered by cloud edge computing and digital twin of the energy systems. And in this action plan, it has been stated that creating a digital twin of European electricity grid will support both customer TSO transmission system operators and DSO distribution system operators. And we can say that the owner of data in the futures and the government, the country, the region that provides some openness of data, we can say that they probably can come up with some innovative data-driven services earlier than the others. Because when data is shared, then new startup, new companies, new business firms can work on it and come up with the digitalization of many verticals, at the same time preserving privacy and other obstacles that we have in our minds. This is the general picture for digital twin of an integrated energy system. Here you see we have a physical integrated energy systems. The data are collected from the sensors from different sectors of energy, and then this data via the 5G and 6G communication and computations come to the virtual world. And in the virtual world, this real data is used to build a virtual twin that will represent the physical systems, but in the virtual space. And if we have a virtual twin that is accurate enough, then we can do anything with this virtual twin without the physical limitation of real worlds. Again, the problem here is access to the data, to the high quality data for building such an digital twin and providing services there, and creation of digital twin through the 5 areas that, for example, the last one, data exchange between TSO and DSO, not only exchange the data, also exchange of the intelligence and the services, as the 6G also will be some kind of service of services, that different services are provided. And at the service level, not only at the data level, they should be able to talk to each other and exchange the intelligence. And for example, for this general architectures for digital twin, this is actually the architecture that a part of our application for Academy of Finland that was submitted, that we have this sensor and actuators, and in the communication network, we have many options, depending on the use cases, depending on the requirements forced by the verticals. Some use cases are not so critical in terms of delay. Some use cases are very critical in delay requirements. And we have many options that they should be well worked together. And then at the fog and edge computing, we have many challenges there. And in the cloud and platform, we have connectivity management, device management, and also shared knowledge and informations. That is very important there, that how the knowledge from the players in the same sector and also from the other sectors are going to be shared. For example, for the vehicle, for the electric vehicle in the futures, for the transportation and autonomous driving, they should be able to share this data with the energy system because they have some mutual impact on each other. And then on top of this data, some kind of hardware in the loop services are going to be offered based on the real data collected from the real physical system, not just like today simulation that we work on the physical or mathematical modelings, and in the futures, or maybe in the, when 6G comes to the digitalization of many verticals, then this is the right time. And there are also many obstacles about the interoperability at the service layer, data layer, communication, and even in the device layers. That is the role of regulation and standardization body, and also users empowerment. And we have some kind of augmented consumer providing easy to understand information and automated and conversational generated insight, and also privacy, cybersecurity, and resilience are always some concerns when we are talking about the digitalization of energy systems. Thank you. That's it. I think that's the right time. Thank you.
Thank you, Mehdi, for your excellent talk and keeping exactly the time. So, do you have any questions? Let's have a look whether we have an event room. No, but Sannam, I think you have a question in your mind.
Thank you, Mehdi, for your presentation. You mentioned that in the future, about 80% of data processing and analysis could be edge computing. What kind of, if we think about the whole ecosystem, what kind of business opportunities or what extra value it could give to end users?
For the business opportunity, I'm not the right person to answer because I'm not businessman, but I can have my own guess. But about the opportunity that this edge computing data can provide is that, for example, currently in the 5G mobile communication, we have the concept of private 5G, that verticals are more sensitive to their data and they want to keep their data in their premises. And so it is important to ensure them that your data, your decision making, and your insight, generated insight, are kept in your ownership. And that's why they come up with some maybe edge or fog computing that is under their control. There are many scenarios for private 5G, and next maybe generation of the private 5G is the local 6G is a project that currently funded by the Business Finland about such an opportunity. And then this data, when they are collected at the edge, at least for the owner of this data, provide much information, because nowadays we have much data from the multimedia, but we don't have much data, for example, for the energy systems. For the healthcare, maybe from the past collected information, collected in a traditional way, I mean, like asking and then they put it in the digital form. But in energy systems, we need some data. And this trend, I think, supports some data-driven innovations in the future for vertical-like energy systems.
Thank you. And now we have a question in Ivanthi. So do you think knowledge and data sharing between multiple parties in a solution provided you have a number of cyber attacks going on? How do you see this?
For sure, when you're expanding your digital platforms, then it at the same time provides a platform for attacker to use these digital platforms. And I think this is the struggle that has been always the case. For example, for when we use over a smartphone, we face the same problems that somebody may access to our data. But at the end, some kind of balance or some equilibrium that we take risk, and then at the same time, we take some cybersecurity solutions, and then we also go to the digital world. I think I'm not the expert in the cybersecurity, but my general direction is that it's like what we did before in the verticals. If they become confident in some acceptable level of risk, then if we can keep the risk below that threshold, then the digitalization can happen. But for sure, we also expect some attacks or some cybersecurity issues there.